The question says that determine the current in each branch of the network as shown in figure 3.20. So this figure shows a network of resistors and a cell, and we have to find out current in each and every branch. So let's proceed with the Kirchhoff's loop rule, which says that potential difference across a loop is 0, and we know that current flows from higher potential to lower potential. We have decided to go with 3 loops. The first loop is A, B and D. The second loop is B, C and D, and the third loop is A, B, C and E, that is this outer loop. So in the first loop, that is A, B, D, we see that we have assumed the current in this direction from A to B. So the potential difference is going to be positive from A to B because the current is flowing from A to B. So we can write it as 10 times 10, that is the resistance, times I2. Similarly, in the arm BD, we get 5 times I4. Now in arm AD, now the loop direction is opposite to that of the current, that is current is flowing from A to D, but our loop is from D to A. So we will write it as minus of I3. Now equating it to be equal to 0, we see that it is 2I2 plus I4 minus I3 equals 0. Now similarly in loop BCD, we see 5I2 minus I4 minus 10I3 plus I4 minus 5I4 equal to 0. This will give us I2 minus 4I4 minus 2I3 equals to 0. Now similarly in the loop ABCE, that is AB, C and E, we will see that 10 times I2 plus 5 times I2 minus I4 minus 10 plus 10 times I1 would be equal to 0. Now this will give us 5I2 minus I4 plus 2I3 equals to 2. Now rearranging these equations, we will see we have 3 unknowns, that is I2, I4 and I3, and we have 3 equations. So after solving this, we will get the value of I2, I3 and I4 as I2 equals to 4 by 17 and I4 equals to minus 2 by 17 and I3 equals to 6 by 17. Now we can find the current in each branch as it is in the form of either I2, I4 and I3, and we can write I1 as equals to either I2 plus I3, or we can write it as I2 minus I4 plus I3 plus I4, or it should be equal to I2 plus I3 only. So current in branch AB would be equal to I2, that is 4 by 17. Current in branch BC, that is this branch, would be equal to I2 minus I4. That will give us 4 by 17 minus 2 by 17. So the current in branch I4 is minus 2 by 17, that is I4 is this branch. In branch BT, we have got current minus in the direction. That implies that our assumed direction is opposite to that of the flowing current direction. So that is, if we have assumed that I4 is flowing from B to D, then the actual current would be flowing from D to B. And that's why the minus sign is there. So using the same approach, we can find the current in BC, AD and BD and AE as well. The current in AE would be equal to I1. Now I1, as I said before, it is given by I2 plus I3, so we can simply add 4 by 17 and 6 by 17 and we will get as 10 by 17. 4 by 17 plus 6 by 17, that will give us 10 by 17. Now each of these currents will be in ampere. Thank you.